Thus, the objective for the experiment is to determine the coefficient of the static friction of different surfaces. The procedure for this experiment is: first, the mass of the wooden block is measured, recorded. Second, the apparatus as shown in Figure 5.2 is prepared. Third, the top of the table is ensured to be stable and horizontal to the group. 4. Spring scale and wooden block are attached with ropes placed horizontally on the table, and rubber part of the block is facing down. 5. A n equal 50 gram mass is placed on a wooden block. 6. The spring is pulled slowly. The block starts to move. The spring scale reading is recorded. Value not SFS and tabulated in table 5.1. 7. Steps 4 to 5 be repeated 3 attempts. 8. 50 gram of mass is added to the wooden block. Step 5 to 6 are repeated. The steps are repeated until the amount of M equal 500 gram of mass is on the wooden block. Lastly, step 1 to 8 are repeated, ensuring that the rubber part of the block is facing up. Data is tabulated in table 5.2. As you can see, this is an apparatus for this experiment.
To show all of you an analysis of our presentation. First, we need to draw and label the free body diagram of the wooden block. Second, plot graph of static friction force, Fs, again normal force, Newton for the rubber surface and non-rubber surface. Third, use the gradients obtained from the graph to calculate the coefficient of static friction, Newton S for each surface. 4. Compare and discuss the coefficient of static friction, mu S obtained.
Of all, I would like to talk about result. Table 5.1, rubber surface towards the floor. The mass of the wooden block with the rubber surface is M equals to 55.3 plus minus 0.1 gram. The mass plus minus 0.1 gram, and the next table is total mass M plus minus 0.1 gram, and the third one is total weight W plus minus 0.1 N. And then we have static friction force Fs plus minus 0.1 Newton. And then we also have trial 1, trial 2, trial 3, and the last one for the first example is mass equals to 50, total mass is 105.3, total weight W is 155.3, the trial 1 is 1.8, and trial 2 is 1.8 also, and the trial 3 is 2.0, and the average will be 1.87. Okay, for the next example, the mass is 100, the total mass is 105.3, the total weight is 205.3, and the trial 1 is 2.2, the trial 2 is 2.4, and the trial 3 is 2.42, and the average is 2.30. Okay then, now I'm going to continue with table 5.2, non-rubber surface towards the floor. The mass of the wooden block with the non-rubber surface is M equals to 53.7 plus minus 0.1 gram. And then we also have mass M plus minus 0.1 gram, and then we also have total mass m plus minus 0.1 gram, and the third table is total weight W plus minus 0.1 gram, and then we also have static friction force Fs plus minus 0.1 N, and then we also have trial 1, trial 2, trial 3, and the last one is average. Okay, for the first example, we have mass equals to 50. The total mass is 103.7, and then total weight is 153.7, and then the trial 1 is 0.2, the trial 2 is 0.2, the trial 3 is 0.4, and then the average is 0.27. Okay, for the second example, we have mass equals to 100. The total mass is 103.7, and then the total weight is 203.7, and then the trial 1 is 0.4, the trial 2 is 0.4, and the trial 3 is also 0.4, and then we will get the average is 0.40. Okay, now I'm going to talk about the non-rubber surface towards the floor graph. And then the x-axis in the graph is total weight Newton, and the y-axis in the graph is average Newton. And then the scale of the x-axis is equals to 2 cm, represent 100 Newton, and the scale of y-axis is equals to 2 cm, represent 0.20 Newton. And then the gradient is divided into 3 components, such as gradient mean, gradient max, gradient base. The gradient mean is equals to 1.6 times 10 exponent negative 3, and the gradient of and the gradient for gradient max is 4.0 times 10 exponent negative 3, and the last gradient is gradient base is equals to 2.9 times exponent negative 3. And the last point in the graph is the midpoint. The midpoint for x is 382, and the last is y. The midpoint is 1.067. Okay, now we are going to moving on with the second graph. The second graph is rubber surface towards the floor graph. The x-axis represents the total weight in the Newton unit, and the y-axis represents the average in the Newton unit. And then the scale of x-axis in this graph is equals to 2 cm, represents 100 Newton, and the scale of y-axis is equals to 2 cm, represent 1.00 Newton. And for the next one, the gradient of this graph is also divided into 3 components, as it contains gradient mean, gradient max, and the last one is gradient base. The gradient mean in this graph is equals to 7.8 times 10 exponent negative 3, and for the next one is gradient max is equals to 0.0165. And the last gradient in this graph is gradient base. The gradient base is equals to 0.01125. And then for the last point in this graph is the midpoint. The midpoint for x in this graph is 380, and the midpoint for y in this graph is 4.27. And then we are gonna moving on to the next one. The next one is mu is equals to friction divided with normal force. And then for the rubber surface, mu is equals to force divided with Newton, and the number is 4.258 divided with 380.3, and the answer we will get is equals to 0.011. And for the non-rubber surface, is mu is equals to force divided with Newton, and the number is 1.054 divided with 378.7, and the answer we will get for this is equals to 2.7832 times 10 exponent negative 3.
There are some questions of our presentation. First, how can anti-lock brakes stop a car in a shorter distance than regular brakes? The answer is anti-lock brake sense when the wheels are about to lock up and slide and is off on braking to allow the wheel to continue rolling, therefore prevent the wheels from locking up and sliding. Second, from your experiment, which material has the highest coefficient of your static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? The answer is the rubber surface have higher coefficient of static friction, and normal force and static friction force is a factor to find coefficient. The last question is, once the mesh begins to slide, does it move smoothly, or does it undergo stop and go motion? Explain the motion. The answer is the mesh will move smoothly because of the sliding friction.
For the conclusion, the coefficient of static friction of different surface was successfully determined. The coefficient for rubber surface is 0.011 and non-rubber surface is 2.7832 multiply 10 the power of negative 3.